So the directions for number 1 will be similar to this. It'll just say in words like find f plus g, state the domain, and evaluate when x is equal to 16. And it'll have lines for the answers for each one. So to find f plus g, we're going to add our two functions together. So -5 times the 4th root of x plus 19 times the 4th root of x. So these are like terms, so we can add them together, and it would be 14 times the 4th root of x. So we just add our coefficients, the variable part stays the same. So when adding or subtracting, we just combine our like terms together. Now for the domain, we have to check the domain of both f and g. So looking at f of x, what's our domain for f of x? Awesome. Whenever we have an index that is even, we set whatever's under the radical greater than or equal to 0. So our domain here for f of x is greater than or equal to 0. So that's when it's an even index on our radical. So what would our domain for g be? Same thing, x is greater than or equal to 0. So for the domain of the whole thing, f plus g, we care about both of these domains. It's what overlaps between the two. So it's usually going to be like the more restricted one if they're different, but here they're the same, so it would just be x is greater than or equal to 0. So next we're going to evaluate when x is equal to 16. So we're plugging in 16 in the answer here into x. So we get 14 times the 4th root of 16. What's the 4th root of 16? 2. If you need to, break it down. We have 4 and 4. 2, 2, 2, 2. Circle your groups of 2. So this would be 14 times 2, which is 28. So our answer here would be 28. What if I had something like x squared plus 2x plus, let's say, 4x cubed? What would our domain here be? All real numbers. Why? Because we don't have any radicals, don't have any fractions as exponents, so it would just be all real numbers. All right, next we're going to take a look at 3, but the dividing part. So going to the next page. So f is 4 times x to the 4th power, and g is 3 times the square root of x. So we want to find f divided by g. So we're going to take function f, 4x to the 4th power, and divide it by function g, 3 times the square root of x. All right, now we want to simplify this. We can't simplify our coefficients, so we could just leave that as 4 over 3, 4/3. But can I simplify the variable parts? How? Perfect. I'm going to change the square root of x to be x to the 1/2 power. That way we can combine them together. So the square root of x is the same thing as saying x to the 1/2 power. What if I had like the cubed root of x? That would be x to what power? To 1/3 power. If I had the 4th root of x, that would be x to what power? 1/4 power. So it's important to know how to go back and forth between the two. So here, I'm going to change the radical to be x to the 1/2 power. And now when we're dividing, what do I do to combine them? Subtract. So this would be x to the power of 4 minus 1/2. How do I subtract a whole number and a fraction? Put the 4 over 1, and what do I need? A common denominator. So what could I change 4 over 1 to be? 8 over 2. Perfect. So when I subtract, the 4/3 stays out front, times x to what power? 7 over 2. We just subtract the numerators. So 8 minus 1 would be 7, and the denominator stays the same, so 7 over 2. So when we divide, we get 4/3 times x to the power of 7 over 2. Let's find our domain now. So for our domain, we have to check the domain of both. What would my domain of f be? All real numbers. We don't have a radical and we don't have a fraction as an exponent here, so it's just all real numbers. What about our domain for g? X is greater than or equal to 0 because we can't have negative numbers, we can't have negative numbers under our radical. So we would set the inside greater than or equal to 0 because it's an even index. So we would take the more restricted domain, which would be x is greater than or equal to 0. However, when we're dividing, I cannot have 0 in the denominator. So x cannot be 0. So how can I say x is greater than or equal to 0 without 0? Just x is greater than 0. So if you're dividing, just get rid of that equal to sign. So it'd just be x is greater than 0. So anytime you're dividing, you can't have 0 in the denominator. So 0 cannot be included in your domain. All right, now let's plug in 4. So we're going to evaluate when x is 4. So we're plugging it into our x. So 4/3 times 4 to the 7 over 2 power, which is the same thing as writing 4/3 times the square root of 4 to the 7th power. What's the square root of 4? 2. So 4/3 times 2 to the 7th power. So 2 to the 7th power would be 128. So this would be 4/3 times 128, which would be 512 over 3, because we just multiply 4 times 128. So it would be 512 over 3, or you could divide it, and you would get 170.66 repeating, or you could say 0.67 if you rounded it. That would be fine too. Either one of these answers would work. So if I had something like x to the 1/4 power, what would my domain for this be? X is greater than or equal to 0 because my index is 4, which means that even index, you can't have negatives underneath. But if it was x to the power of 1/3, what would my domain be here? All real numbers.
And if it was something like 3/4, it doesn't matter, it's only the x.
X is greater than or equal to 0. Yeah, if it was something like x is 3/4, you're looking at the index. So that 4 on the bottom means that it would be x is greater than or equal to 0. So number 4, we have to find the inverse. So first step in finding the inverse is switch our x and y. So f of x becomes x, x becomes y. So x is equal to the cubed root of y plus 5/2. Now our goal is to undo everything on the right side. We need to get it to be y equals. That y has to be all by itself. So just be careful. Just do one step at a time. What would we do first? Do I times 3? We do an exponent of 3 because to get rid of the cubed root, we have to cube both sides. So both sides gets raised to the 3rd power. So x to the 3rd power is now equal to y plus 5/2. What would I do next? Awesome. Y is being divided by 2, so the opposite of division would be multiplication. So I'm going to multiply this whole side by 2 and multiply this side by 2. So we get 2x to the 3rd power is equal to, cancels out here, so y plus 5. What's the last step? Minus 5. So 2x cubed minus 5 is equal to the inverse of y. Don't forget to name your inverse. Need that little -1 symbol on the y. All right, let's look at number 6. So here we're determining if they are inverse functions of each other. So it would say, determine if the two functions are inverses. So to determine if they're inverses, you take one function, plug it into the x in the other. So here we would have 1/2 times the 5th root of 2x to the 5th power. Just be careful. A lot of people just want to cancel out everything, but it depends on what you're doing. If you have a +2 inside the radical and a -2 outside, those just don't cancel out. You have to get rid of the radical first. So what would cancel or simplify here first? The 5th root and the 5th power. Perfect. Because this whole parentheses is being raised to the 5th power, and it has the 5th root, so it will just cancel. So I have 1/2 times 2x. What's 1/2 times 2x? X, just 1x or just x. Perfect. Let's do the same thing the other way. So I have the 5th root of 2 times my whole function here. So 1/2 x to the 5th power. What would cancel out or simplify first here? Perfect. Awesome. The 2 times 1/2 would just become 1. So then I just have the 5th power of x to the 5th power. Or the 5th root of x to the 5th power. Anything cancel here? Perfect. The 5th root and the 5th power. So we're just left with x. So I get x is equal to x. What does that mean? Yes, they are inverses. So next, let's take a look at our logs. The first part here says tell whether the function represents exponential growth or exponential decay. So we have to look at the number that has the exponent. If that number is greater than 1, it's exponential growth. If that number is in between 0 and 1, it's exponential decay. All right, so number 1. I'm looking at the 4.25, which is greater than 1. So it would be growth. Perfect. For number 2, looking at the 3/8, that would be decay. Awesome. Be careful because not always are your fractions going to be less than 1. What if I had something like 7/2 to the power of x? Would this be growth or decay? Growth, because 7/2 is greater than 1. So just be careful. So next, we're going to simplify the expression. So let's look at number 8. So here, we have e to the power of ln of 9. What's the same thing as saying ln? Log base e. So it's e to the power of log base e of 9. How do we simplify this? E to the power of log base e. Since our bases are the same, they cancel. So what's our answer here? 9. Awesome. So you could also just know that e to the power of ln cancels out, and you'll just be left with 9. All right, let's look at number 9. Here we have log base 7 of 49 to the power of x. We don't have the same base and the same number here, but could I make it have the same number? So how can I make 49 into 7? Perfect. I'm going to change 49 to be 7 squared. And whatever my exponent is, it just gets multiplied to the exponent that's already there. So this is going to be log base 7 of 7 to the power of 2x. So you want to change whatever your number is here to be the same as your base, but just change it by giving it an exponent. So I'm not changing the value here. I'm not dividing by 7. I'm just changing 49 to be 7 squared. These are the same thing. 7 squared is the same as 49. Just looks different. So what cancels here? Log base 7 of 7, and what am I left with? 2x. Here we're not solving for x, we're simplifying. So you still have x in your answer. It's not x is equal to, it's just still in your answer. So let's say I had log of 10 to the power of 2x. If I don't have a base written there, what's it implied that my base is? 10. So if this is log base 10 of 10, what would this simplify to? 2x. Perfect. The log base 10 of 10 cancels, and we're just left with the exponent there. So I want to change 81 to have the base of 3. That way they'll cancel. So 81 would be 3 to what power? 3 to the 4th power. So let's change this to be log base 3 of 3 to the 4th power times negative 2x. So log base 3 of 3 cancels. And what am I left with? Negative 8x. We just multiply these two together. All right, for the next section, 11 through 14, we're just rewriting the expression in exponential or log form. So if it starts with a log, we're putting it into exponential form. If it starts with an exponent, you're putting it into log form. So we start with the base. What would come next? 4 to the 5th power is equal to 1024. Perfect. So you start with the base, the other two just flip positions. Let's look at 12. How would we put this in exponential form? Perfect. 1/3 to the power of negative 3 is equal to 27. Yeah, you're rewriting, you're not solving, you're just rewriting. So this one we're putting it into log form. So log form, we need to start with a log. Is equal to 4. Yeah. So you always start with the base and then flip the other two. All right, and 14. So we're putting it into log form. So start with log. What would come next? Of is equal to negative 2. Awesome. You just switch the position there. Number 16, we're just putting it right into the calculator. Just be careful because ln is a different button in your calculator than log. So here I'm taking the ln of 1.4. So that would be 0.3364. If we round to 3 decimal places, we look at the 4th, and that tells us if we round up or stay the same. Do I round up or stay the same? Stay the same, so it'd be 0.336. Right, there's no graphing on the test, so we're going to skip 18 and 20. Let's look at 24. So you purchase an antique lamp for $150. The value of the lamp increases by 2.15% each year. Write an exponential model that gives you the value y in dollars of the lamp t years after you purchased it. So our formula for exponential growth or decay is p times 1 plus r to the power of t, or p times 1 minus r to the power of t. A equals? Oh, it's y equals. It's the same thing. P or a is just your starting amount. We can say y equals. So for this one, are we using the plus or the minus? Why the plus? Because it says increases. So if it's increases, use the one with plus. If it says decreases, we use the one with minus. Decrease, it could say decreases, decreasing, getting smaller, anything like that. All right, so let's plug in what we have. What's our starting amount? 150 times 1 plus, what is r? What's our rate? Perfect. We have to take our decimal and move it 2 times to the left. So it'd be 0.0215 to the power of t. We're just writing an exponential model, so we're not solving here. We're just writing the equations. We don't have a value for t. It doesn't tell us how many years, or it doesn't ask us to evaluate. So we just leave the t in it. So this would be 150 times 1.0215 to the power of t. So this question could have like a part B. So like this was A, to write a model. Part B might say, find the value of the lamp after 5 years. So how would I find the value of the lamp after 5 years? Put 5 in the t. So I have 150 times 1.0215 to the power of 5. And then here we would just put it in our calculator. 1.0215 to the power of 5. And then times 150. And you should get 166.83. Since you're dealing with money, you just round to 2 decimal places. So this would be the answer to B, question B that I made up. So whenever you're dealing with money, just round to 2 decimal places. It's not going to tell you. You got to know. Money, 2 decimal places. So the next one, number 4, says you deposit $1,500 in an account that pays 7% annual interest. Find the balance after 2 years when the interest is compounded daily. So interest questions have a different formula. Anytime it says compounded interest or interest and it's compounded a certain amount of times, our formula is A is equal to P times 1 plus R over N to the power of NT. So we need to find P, R, N, and T. What's our P? 1,500. P is the starting amount. That's how much we deposit in an account. What is our rate? Awesome. It gives us 7%, but we have to change it to the decimal. Anytime you're doing these questions, your R is the decimal version of the percent. So you move the decimal 2 times to the left. So 0.07. N is the amount of times that it's compounded a year. So if it's compounded daily, how many days are in a year? 365. And T is time. How many years are we looking at? 2 years. So let's plug everything in. I have 1,500 times 1 plus 0.07 over 365 to the power of 365 times 2. So be careful here. Make sure you know how to put this in your calculator. Follow your order of operations. I'm going to do 0.07 divided by 365 first. Then plus 1, and you should get 1.000117. We're going to say ... but just keep it in your calculator. Now we're going to raise it to the power of 365 times 2. So if you keep this in your calculator and you do to the power of 365 times 2, make sure you put this in parentheses. You got to put it in parentheses or multiply it first, so then you're just raising it to the power of 730. If you don't put it in parentheses, it may think that you're raising it to the power of 365 and then multiplying that whole answer by 2. So we should get, when you do that, 1.1502. Just keep it in your calculator when you multiply the 1,500. So times 1,500, you should get 1,725.387. We're dealing with money, so how many decimal places do I keep? 2. Does a 7 tell me I round up or stay the same? Round up. So this would be 1,725.39. And we're talking about money here, so a $sign. No, so N changes depending on how many times it's compounded. So if it was compounded annually, how many times, what would N be if it's compounded annually? How many times does that happen a year? 1. What if it's semi-annually? 2. What about monthly? Monthly, N would be 12. What about weekly? Weekly would be 52. Quarterly. Quarterly would be 4. We'll add daily on there too. Daily is 365. All right, so let's look at 11. We're evaluating the logarithm. So this log base 2 of 8 is equal to some number. So it would help us if we put this in exponential form. So 2 to the power of x is equal to 8? 2 to what power gives us 8? 3. Awesome. So x would be 3. So the same thing for 12. This is equal to some number x. So 6 to the power of x is equal to 1 over 36. What type of exponent do we need to turn it into a fraction?
Negative.
Awesome. Negative. 6 to what power gives us 36? Awesome. Negative 2 would be our answer. And then 13, this is equal to some number x. So 5 to the power of x is equal to 1. 5 to what power gives us 1? 0. Awesome. Anything to the power of 0 would be 1. Okay, so I want to take a look at, this is 6.1, example 2. So it says the value of a car Y in thousands of dollars can be approximated by the model Y is equal to 25 times 0.85 to the power of t, where t is the number of years since the car was new. Tell whether the model represents exponential growth or decay. Why decay?
The value of a car over, how the value of the car degrades over years. It says, wasn't it years since
You're right, but why? Because it's a decimal. The 0.85, the number that has the exponent, is less than 1, so it'd be exponential decay. Part B says identify the annual percent increase or decrease in the value of the car. So we know that it's decreasing, so I'm going to cross out increase. So the percent decrease. How could I find the percent that it's decreasing? This 0.85 comes from 1 minus 3. Because since it's decay, we're using the 1 minus formula, that a times 1 minus r to the power of t. That's where this comes from. And it's 1 minus because we said it was decaying. So 1 minus r is equal to 0.85. So we would solve for r. How would I solve for r? Subtract 1. So r is equal to negative 0.15. So r is equal to 0.15. So that's our rate. But how do I find the percent? Multiply by 100. So what percent of decrease do we have? 15%. Awesome. If it asks for the percent, make sure you give me the percent. It's not 0.15%. You got to multiply it times 100 to turn it back into the percent.